So welcome to video 6 in our introductory videos on B08 Data Visualization. Here we're looking at heat maps in base R and using functions that are similar to ggplot. So there's quite a few ways of different making heat maps, and we remember why we want to use them. There's lots of options, but they may or not be suitable for whatever particular question you're looking at. So they're most effective for you looking at hard to interpret numerical data that you want to summarize quickly. That could be for yourself, because you're doing QC and you just want to see the general patterns, or maybe for a viewer where you have a really big table and it's difficult to decide how best to communicate that information. There's only so many rows and columns that people can really understand properly. So that's where heat maps can be effective. One package that's useful created for any heat maps out of the many options that are available is gplots. So we install that using install.packages and activate it with the library command. And that will allow us to create heat maps. So what most heat maps have is some sort of color scheme, color palette, like red to yellow here, that denotes the values that we had in our input matrix. You can see the frequency on the legend on the y-axis here. You could also note that this legend is not very well designed yet. It needs to be bigger to view it properly. And that matches this color scheme here. You can sort of see there's a trace line showing the frequency distribution as well. And you see that trace line going through these colors here, but that's something we'll remove in these plots. You'll see here these dendrograms are also here. We can use them to sort, so to reorder normally here we'd have the samples on this as the rows and then the features as the columns. We can sort them by the rows of columns, column values based on the dendrogram order, and the dendrogram will typically use some sort of bottom-up clustering algorithm, but know that the type of clustering algorithm may differ, and that's something to think about carefully. If you're using genetic data, you know that the dendrogram is a very, very poor proxy for phylogenetic methods that will give a more evolutionary interpretable model of what really happened in terms of the sample's genetic history. So don't avoid interpreting the dendrograms in that sense. So what you can see here is that each of the values for each item is colored here as an entry for feature 19 for sample 4, and then we can just repeat that for all the different samples as we go along and look at their values very, very quickly. So you can see sort of immediately that for the samples that there's certain pairs that are more similar and certain groups like this more similar, though each of the longer external dendrogram branches can indicate that each sample here is quite different from each other. So as input data, what we can use is just create some vector y with 200 values where there's sufficient noise to differentiate them. And then what we're going to do is create a matrix that's a 10 by 20 table. We're taking the square of those values just to make it more like maybe gene expression, protein expression data. And then we're creating a matrix from that. And then we can view it to check that it looks okay. If we do that, we'll look at something like this. We see there's arbitrary column names given there, and these are our arbitrary row names that are just adequate for now. And then we can plot that to get that sort of diagram that we had before. So this is the default plot type, and we can modify that as we go along. So that's with the function heatmap.to. So we're just taking our XX matrix there. We put XX here instead, and we can also see it's a bit ugly, it needs a bit of work. So what we can do here for our values, depending on our approach, is firstly scale them. So we can scale the values. We're scaling by row, so we're normalizing across the different samples here so that the samples are more comparable to each other. So if we do that, we'll see that we went from this original graph, and you note that the legend changes. So we've got Z normalized scores where the mean value is 0. You do see from the trace diagram that the Z scores do not show a normal distribution shape. And you'll also see that the dendrogram on the left and for the rows and also for the columns, they're the exact same, but the shading has changed here due to that normalization procedure. So you've got fewer samples that are more red. In some senses, it's easier to interpret visually because it's a better use of color here in terms of differentiating the values. We can do further things. So we can remove the blue trace. If we do that with a different plot here where we have a red to pink color palette. So color ramp palette is a function that can give us different colors depending on what we put in. We can change red and pink to whatever you want. You can see there that we have removed the blue trace. You know the dendrograms are the same here. We've just changed the color palette. If we take another example, we can add on more features here. So there's things like we can remove the labels for the rows and the dendrogram as well. So we can remove the X and Y lab labels, we can add them in, or here we're set them to null, so there's none. We're using a kind of a blue color scheme here. ACL.colors is another function to create a color scheme depending on how many colors we want, like 10. I'm going to change a blue YI to a different color scheme. The trace is off. There's no legend key. The dendrogram is set to none. And what we're going to do is add on row site colors to denote our samples. So we might have groups here. And here we're just for effect, we're just adding groups arbitrarily allocated as blue, orange, green, purple, and gray. And we're just repeating them twice each. So that means we get this order repeated twice. And then we're adding column colors because we might have features that are maybe associated with particular macro level biological information that's of interest to us. So if we do this, what we'll see is that we kind of get this green, yellow color scheme for our values. And then we have the samples here. Maybe these colors have some sort of logic to them. And then same for the column is across here. So we can make heat maps that are more informative. We retained the column names in this example. So you can see that we can layer on other information and also remove like the dendrograms. Say we don't want those, we can take those out. So we're not adding too much chart junk that we may not want. If we look at more examples, we can use this function expand.grid. And here we're just taking an example where you have a bunch of letters in the alphabet, 1 to 20. So that's A down to the 20th letter. And then we're pasting with 0 var 1 to var 20 here as well. So that creates a kind of table where we have 1 is the label and 2 is another label for the different groups. And then the values are after that. So that's tidy data. So we got a label, and a value. Label, values. That's like the names we had before. It's the same structure. We're adding values in here, just using the run if function for our values. And we're putting that into the column Z. Then we plot that data, comparing X versus Y, where the fill is the values. We're tidying that using the GM tile function. And then we've got this function scale fill gradient here. We're going from white to blue. And we've changed those colors if we want to do as well. So we're looking at that data like this. So you have A, B, C, D, and so on, var 1, var 1, var 1. And we could change that to a different entry as well if we wanted. And then if we plot this, what we'll get then is our samples here, our features here across the columns, and then our samples here on the y-axis. And you see that we have the legend on the right-hand side, this. So this is a kind of a ggplot version of the same thing, just showing a kind of a different way of representing the same sort of data. You can see that it's just a data frame or matrix as input. So if you look at this, we can change the colors. We can take that same diagram and change the palette to red and purple, red RTPU. We'll get something like this. So it's different color scheme depending on what you think is most effective. And we can also visualize in different ways, and we'll talk about that more in our lab. So what we'll talk about in the labs then is basically how you can write your own code, your own data set, if you have your own data set, to make heat map input data. We can toggle the heat map parameters, add additional info onto heat maps. I'll talk also about the data source data as well that we can manipulate in the lab. So please look at the demonstration videos for more.